everyone, welcome to my channel. Today I'm gonna talk about the merge sort. Merge sort uses an idea called divide and conquer, which is commonly used in the program design. In this video, we only talk about divide conquer in sorting. Okay, I shuffled a sequence of number through 1 to 11. What is divide and conquer? We first divide in half, find the middle point. Okay, and then divide another half, and then divide by another half. So for both sides, we do the same operation. Then we get each individual number here. After we divide, then we have to merge into a new sequence. Okay, from the bottom to top, we have two elements here. It's already divided. So these two, I will merge. How I merge? I compare this array and with this array. This card with this card, we put 6. And I compare J with the empty. I put J here. Okay, for this one, we do the same thing. We compare 9 and 10. We put 9. Empty and 10, put 10. A compared to 8. So A, I'm not using the A's. This is representing 1. So 1 compared to 8. This one is smaller. And then 8 to empty here. And 4 compared to 8. 4. And then 8. Okay, now we go to the second level. Second level, we have 2 cards on left and 2 cards on the right. I divide by half. So I compare the first one with this one and I get smaller one. And then I compare this one with this one, got a smaller one. Compare this one with this one, get a smaller one. And this one will be empty. For this side, I do the same operation. Compare this one with this one, we got a smaller one. This one with this one, we got a smaller one. This one with this one, it's the tie. So whatever order I can put. Okay, this is the second level, and then to the top. So this is the top level. This is the middle point. On the left side, I compare 6 with 1. Put 1 here. 6 with 4. Put 4 here. 6 with 8. Put 6 here. 8 with 9. Put 9. Put 8 here. 9 with 8. Put 8 here. 9 with empty. 9. 10 with empty. 10. J was empty. J. This becomes a sorted array. This is the idea of merge sort, and it uses the divide conquer method. Okay, let's get started on coding the merge sort. So for the merge sort, we use the divide and conquer, and a typical way to implement the divide and conquer is using the recursion. What is recursion? Recursion is to call the function itself inside the function. Let me give you an example. If I want to loop through this list, I have 2 ways. One is a for loop and one is a while loop. The third way to do it is by recursion. So let's define a function called recursion. Parameter A means an array, and the index means the index of the array. And inside here, we want to call itself. The index will be +1, so we will go to the next index. And before I call it, I will print out the current number. I need an AND condition. So if the index is larger or equal to length of the array, I terminate. When we call this function pile 0, it will recurse through the list. Okay, now we know the recursion. In the merge sort, most complicated one is the merge. So we divide the array and then merge the array. Let's do the merge first. Okay, I define a merge function. It will take an array and a start point. So for this list, the start point will be the index 0 and the value is 2. I have a P, Q, and R. Q is the middle point. R is the end index. Okay, let's use this list as a test. Given this list, I want to merge the left part to the right part. As I illustrated using the pokers, we first compare 2 with 6, and then we put 2. And then I go to the next element, compare with 1 with 6, and I put 1. And compare with 23 with 6, and I go to 6, and until the end. In this case, even I merged them, I still couldn't get the correct order because the left side is not merged and is not sorted. The right side is also not sorted. But if in the recursion way, we will go from the smaller one to the larger one. So everything will be sorted before merge into a larger sequence. Let's use this one, just a test of our merge function. So we need to define a variable to record the length of left array. It will be Q the midpoint, minus P, and plus 1. So this is the length of left. And then I define a length of right will be the R minus Q. I will split them into a left array and a right array. So I create empty array and another empty array for right. I would like to store the left side to the L and the right side to the R. So I use a loop. I equal to the array. The start point is P. So I have P plus I. Another one, the right, equal to, so from the middle point, and a plus 1 until the end. We initialize the L and R, and then we want to merge. So I define a I index from 0, J index equal to 0, and the K index equal to the start point. We check while the I is less than the length of left and J is less than the length of the right. I'll do the loop like until one of them reach to the end of the array. I will check if the left one small equal than right one. Okay. If this one is small, I will assign this one to the original A. Else, I just assign the R, and I have to increment the I and increment the J. After this condition, I increment the K till the end. Okay, I compared and assigned everything. What if I left some element? So if the I is still less than the left length, I will keep assign the left side to the array and increment I and increment K. Or if my J is less than the right array's length, we assign the right part to the array and the increment J and K. Okay, so this is the function I wrote and I want to test. Middle point here because 0, 1, 2, 3, 4, 5, and I compare 2 with 6, I got 2, 1 with 3, I got a 1, 23 with 3, got a 3, 23 with 12 got 12. 23 with 0 got 0. 23 with 87 got 23. 4 with 87 got 4. 5 with 87 got 5. And 6 with 87 I got 6 and 87. Yeah, so that's correct. The merge is correct. And then we do the divide. So we define a merge sort. I will input the array and the start point and the end point. The end condition, it should be if the p larger or equal to r. So if p larger or equal to r, I just return. And then we do a merge sort on the left side. So how to define left side? We use the midpoint. Q is defined by the p plus r divided by 2. So we have a, and left side is p and q. For the right side, we have the array and start from the q plus 1 and then until the r. Okay. And then at the end we do merge. So we have a and p and q and r. Let's call this merge sort. So we have the p is 0 and r is the length of the array, length of the pile minus 1. Okay, let's clear this. Wrong. Yeah, so here is a sorted array. Like this. We can test more. Maybe 3, 1, 3, 5, 6. Like I put some random thing here. Let's put into the pile 2. Oh, this is not correct because I used the pile. Okay, then I got this. Okay, that's the merge sort. Next video I will talk about the algorithm time complexity analysis, and I will compare insertion sort and merge sort. See you next video. Thank you.